So now we want to consider the special angles of 60 and 30 degrees. So we start with an equilateral triangle. So with the size 2 units as we have in the first triangle. Then, supposing we decide to bisect this triangle, supposing we bisect it into 2 equal parts, so we have a dividing line. I divide this line into 2 equal parts. And this point we call, let's say this is point C. So when this is done now, if you go back to the other triangle, so we now have here. So here will be our A now, and this place will now be our C. So this is the point C, and here becomes D. So finally, what do we have? The dividing line now, we bisect this angle 60 into 2 equal parts. So when that is done here, so we now have that here is 30 degrees. So we have here to be 30 degrees. Then the other side here, then line BD is 2. So when this line divides them, here will be 1, and the other side will be 1. So we work here now. So here will be what? Here becomes 1. Then finally, this line will make an angle 90 degrees. So here we'll call the right angle here. So here will be 90. Then here we'll still retain our 60 degrees. So here is still our 60 degrees. Then on the other side, here still remains 2. So here still remains 2. So the only place we don't know now is line AC. And by Pythagoras theorem, if you use the Pythagoras theorem, remembering that we're working with a right angle triangle and having the two sides, the Pythagoras theorem will give you here your known to be equal to √3. So with this now we are set to get the sine, the cosine, the tangent on sine 60 and 30 degrees. So we start with 60 degrees now. So we work with angle 60 degrees and we will concentrate on this triangle. So we concentrate on this triangle. So we are we're going on angle 60 degrees and we are working with the triangle ACD. We are working with triangle ACD. Okay. Now we start. So we look at tan 60 degrees. We remember what the tangent is the opposite over the adjacent. So we look at the side that is opposite to this angle 60 degrees. So that will be line AC. So it is line AC. Then the adjacent, the one that is adjacent is line CD. So we have line CD. So this will now give us, so the line AC now, which is opposite, is given as √3. And the line CD, which is given as the adjacent to that angle 60 degrees, is given as 1. So this is equals to √3. So what we have gotten is that tan 60 degrees now. So tan 60 degrees is equals to √3. So we can go further and look at the sine of 60 degrees. So we have sine 60 degrees. Again, we remember the sine. Sine is presented as opposite over hypotenuse. So we look at the side that is opposite to this angle 60 degrees. It still remains line AC. So line AC is opposite. Then the hypotenuse is the longest side, or the side facing the right angle triangle, which is line AD. So we have line AD. So again, line AC. So if you look at what we have is line AC. Line AC we have √3. So line AC is √3. So we're going to write √3 here. So this is equals to √3. Then we go back again to line AD. So line AD, what do we have there? That's the hypotenuse. What we have there is 2. So we now have here to be 2. Okay. So at the end of the day, what we have gotten is that sine 60 degrees is equals to √3 over 2. Then again, we go further and look for the cosine. So cosine is the last one we consider now for 60 degrees. So we are looking at cos 60 degrees. So remember, the cosine is the same thing as the adjacent over hypotenuse. So we go and look at the adjacent. The adjacent we have here is CD. So the adjacent is line CD. Then the hypotenuse we know is given there as line AD. So we have a line AD as the hypotenuse. So this now will be equal to, so line CD is giving us 1. So here we give us 1. Then over line AD, the line AD is giving us 2. So we have 2 here. So we have 2. So at the end of the day, what we have gotten now is that cos 60 degrees now is equals to 1 over 2. So we now go back again and look for the 30 degrees. So we are done with 60 degrees now. So the 60 degrees, we have gotten the tan 60 degrees. So we got tan 60 degrees, which gave us root 3. Then we also looked for sine 60 degrees, which gave us root 3 over 2. And finally, we got that cos 60 degrees now, cos 60 degrees is the same thing as 1 over 2. Then we now consider the case of angle 30 degrees. Again, we still consider the triangle ACD. So we are still working with triangle ACD. So now we first consider tan 30 degrees. So remember what tangent is: opposite over adjacent. So we'll go and look for the side that is opposite to angle 30 degrees. So if you look at this is angle 30 degrees, okay? And this angle 30 degrees is facing this side. So it's very important. So remember, we are not working with angle 60 degrees now. So things will change. So angle 30 degrees now is facing this line CD. So the opposite now, so the opposite becomes line CD. Then over the adjacent. The adjacent now, remember, we have line CD. So this line CD is opposite to angle 30 degrees. Then this line, the one facing this right angle, so the one this face is always the longest side, which we refer as the hypotenuse. So therefore, the remaining side now, which is this line now, will become the adjacent. So now the adjacent is now line AC. So we have line AC now. So this will now give us, so we have this to be equals to, so we go and find line CD. So line CD, what we have there is 1. Okay, so we now have 1 here. Then line AC, in line AC, what we have there is root 3. So we have here to be what? Root 3. So finally, we have gotten that tan 30 degrees is the same thing as 1 over root 3. Then we go back again and look for the sine 30 degrees. So recall what sine is. Sine is opposite over hypotenuse. So as usual, the sine that is opposite is line CD. Opposite to angle 30 degrees is line CD. Then over the hypotenuse, like we said, the hypotenuse is the longest side. That is the side facing the right angle, which is line AD. So we'll have line AD. So that will now give us, so line CD. So what we have there in CD is 1. So that gives us 1. So we have 1. Then over line AD, so line AD is the longest side, which is 2. So we have 2. So therefore, sine 30 degrees is giving us half. So we have here to be sine 30 degrees, and we have that sine 30 degrees is now 1 over 2, or half. And finally, we look at cos 30 degrees. Now for cos 30 degrees, we remember what cos is adjacent over hypotenuse. We go back again and see what we have there as the adjacent. So the adjacent is AC. The one that is adjacent to angle 30 degrees is AC. We have our line AC. Then over the hypotenuse we say is the longest side, or the side facing the right angle, which is now line AD. So this now will now give us, so line AC is giving us root 3. So we have this to be root 3 over, then line AD is giving us 2. So we have here to be 2. So what we have gotten is that cos 30 degrees now is now equals to root 3 over 2. So we have to take note of these deductions. What we have gotten in the tan of 60 degrees, the sine of 60 degrees, the cos 60 degrees, tan 30 degrees, sin 30 degrees, and finally cos 30 degrees. So we take note of them, and maybe we copy it in our notebook, and we'll always refresh our memory with that, because in the couple of examples, we're making use of these deductions to walk through our examples.